All right, so yesterday we learned that x-intercepts were also called zeros, solutions, and roots. And we looked at graphs of lines and graphs of identified the x-intercepts from the graphs. If you think back to yesterday, and I'm just going to make up something here, we had y equals 7x plus 2, and that was graphed for us, and we identified our x-intercept. Or we had a quadratic, so y equals x squared plus 4x plus 7. I don't know, that doesn't even work. But we had the graph x-intercepts. Today what we're going to do, that's a horrible example, today what we're going to do is we're going to take the equations and we're going to find our x-intercepts from the equation. Here's the thing. To find our x-intercepts here, if you remember, the x-intercept is where our y value is 0. We're going to make our y here 0, and we're going to solve for x. X-intercept. So we kind of have 3 steps here when we're working from an equation. If we have a quadratic, we need a factor. Once we have factored, we end up with 2 binomials, and we need to set each binomial equal to 0. So just like we did here, because we want to make the y value 0, and then we're going to solve for our x. And I'm going to use the word variable x. Our variables not always look right here. Sometimes it's not represented by an x, but it is still the x-intercept. Now, in our class in algebra, we are basically going to be solving quadratic equations. So we're going to focus on that. Here we've got a quadratic equation. Remember, we talked about this yesterday too. It could look like y equals, it could look like 0 equals, and it could look like a function f of x equals. Any of these could be right here. What this is sort of our y. And here it's already been set to 0. So what I'm going to do is I'm going to take each binomial one by one. I'm going to set them equal to 0. So x minus 1 is equal to 0. And then I'm going to solve for my x. Here I 1. Remember, we are finding our x-intercept. So another way to write an x-intercept other than x is equal to 1 is 1, 0, because our y value is 0. Then we do the same for our second binomial. X minus 7 equals 0. Add 7 to both sides, and x is equal to 7. Also written as 7, 0. Or to take this the way it is, or distribute it out and come up with sort of the quadratic form of the equation, you would see that this went through the x-axis at the point 1 and the point 7. Number 2 is another example that's already been factored for us. So we have 2 binomials. We're going to set our y equal to 0, which it already is, but we're going to do it piece. Minus 8 is equal to 0. Add 8 to both sides, and n is equal to 8, or 8, the 0.80. And then the second one. N minus 4 is equal to 0. Add 4 to both sides. N is equal to 4, or the 0.40. is not factored for us. We have m squared minus 12m plus 32. This is sort of what we were calling an easy trinomial because the coefficient of our m squared term is already 1. So we are just going to look for factors of 32. So two numbers that multiply together give you 32, but add to negative 12. And to multiply to a positive, but two negative factors here. And we end up with m minus 8 and m minus 4. And then we're going to set each of these equal to 0, one by one. M minus 8 is equal to 0. Add 8 to both sides. M is equal to 8. So our first first x-intercept is the point 8, 0. And then m minus 4 is equal to 0. Add 4 to both sides. M is equal to 4, so we have the point 4, 0. Number 4 is also a easy trinomial. Factors of negative 35 that add to negative and a negative, we're going to have a positive and a negative. And we end up with x plus 5, x minus 7. So first binomial, x plus 5 is equal to 0. Subtract 5 from both sides. X is equal to negative 5. So our first x-intercept. And then x minus 7 is equal to 0. So add 7 to both sides. X is equal to 7. And we have the point 7, 0. Number 5. Number 5 is not a easy trinomial. We've got minus 32. Since our coefficient here is not 1, the first thing we're going to do is see if we have a GCF. 21, 4, and 32, we do not have a GCF, so we're just going to move straight into slide and divide. And we're going to multiply 21 by 32. So x squared minus 4x minus 672. 672 is pretty big. You might need to dose. Okay, so I think what I'll do, if you bear with me while I pull up my Desmos, I think what I'll do is go ahead and just refresh our memory on how 672. And I got a voicemail from Lee Hayden up there, just so you know. So 672, do I need y equals y? Nope. 672 divided by x. Just kidding. Okay. So 672 divided by x, then you have a table. And we don't have, this is giving us factors, but we don't have what we need yet because we need to add to negative 4. So remember, when we have a negative and a negative, we're going to have one positive and one negative. And you could put a negative 672, but you're going to have to try to match up your signs either way. So I usually just look for the 672 that add to negative or positive 24. All right, let's try again. So because we have not gotten anywhere close, keep scrolling down through, and you're going to have to go pretty far. Before I keep going down to where we're headed. Notice, remember, when our negative sign is in the middle, that means our bigger factor is going to be negative, and the smaller number is going to be our positive. So if you were to keep scrolling down, and 28. If I were to make this a negative 28 and that a positive 24, I would get a difference of negative 4. So my factors here are going to be x plus 24, x minus 28. Now, we did slide and divide. So because we did slide and divide, now I need to do my divide. So we're going to divide each of these by 21. It's fine, go. And then we can't divide evenly, so I'm going to reduce each fraction, and we end up with x plus 8/7 and x minus 4/3, and then we need to move our we would want to move our denominator over. We don't need to here because we're trying to solve for x. And so if I scooch my denominator over, I'm going to need to have an extra step when I solve for x after setting them to 0. So instead what I can do is say, well, x plus 8/7 is equal to 0. Now I can just subtract that whole 8/7 away. And we get x is equal to 7 or negative 8/7. 0, which you can't see. So we end up with a fraction, which obviously is a little bit more realistic than always ending up with a whole number if you're doing actual, say, data work. And last we have number 6. Number 6 is also not giving us a coefficient of 1. Our 5, so we're going to slide and divide. We get m squared plus 19m minus 150. So factors that multiply to negative 150 add to 19. We got m plus 25, m minus 6. And here we can go ahead and simplify m plus 5. Because I'm going to solve for this m, I'm going to leave this as a fraction. And now I can take the binomials one by one and solve for m. So m plus 5 is equal to 0. Subtract 5 from both sides. M is equal to negative 5. So our x, or our m-intercept, is negative 5, 0. Then m minus 6/5 is equal to 0. And I can just add that whole fraction to both sides. And m is equal to 6/5. And so yesterday we looked at graphs, and I can also call our zeros our solutions and our roots. Today we took equations, we set them equal to 0, and we solved for our x-intercepts algebraically.